I do. Here you go. Come and get it. Throw the pencil. Okay, I'm gonna throw an eraser first. No, throw it this way.
Oh,
do you need two? Rodrigo, you need one as well? Oh, okay. All right.
That's why I was born to play wide receiver, man. You think that?
All right.
I was born to play wide receiver as a baby. I was more like a water.
Let us begin. Okay. So last time, do you remember we did asymptotes and they were like at the ends of the graph? You remember this? Okay, so we're all gonna lock in. We're putting computers away so we're not distracted. Okay, so that we cannot take forever on this topic. So you are going to find asymptotes today still, but instead of having the graph, you're gonna have to do it from the equation. Now, if you had me last year, okay, we covered Bobo, Botan, and Betsy. Okay, but listen, if you didn't have me, it's okay because generally this concept really isn't that hard. There are just several special cases we have to go through. So it's Bobo, B-O-T-N, Botan, and then B-E-D-C, Betsy. So these rules are going to help you determine what the ends of the graph do. We'll start with Bobo. Bobo stands for bigger on bottom. Okay, and when I say bigger on bottom, that is referring to the larger power of the equation being on the bottom. So I'm going to give you an example. We'll put 5x squared plus 7x over 10x cubed plus 5x. So when I say bigger on bottom, we're talking about the power. So what I mean by that is circle comparing x squared versus x cubed. The x cubed is bigger and it's on the bottom. Okay, the last O in Bobo, bigger on bottom, means that the ends curve to 0. Okay, the ends curve to 0. So we're going to do a sample graph, but remember, horizontal asymptotes don't tell you what happens in the middle. They only tell you what happens at the ends. So in the middle, I'm just going to do a crazy graph. We don't know what happens in the middle, but we know the ends need to curve off to 0. So that would be here. And then we'll make this one go here. Okay? But at the ends of the graph, if it's a bigger on bottom, the ends approach 0. Okay? Botan. So Bobo's bigger on bottom. What do you guess Botan is?
Bigger on top.
Bigger on top. Very good. So my bigger power is on top. And in that case, there is no horizontal asymptote. I'm going to give you an example of an equation, then an example of a graph. So we're going to take that same equation we just had here, and I'm just going to flip it. So my 10x3 plus 5x is at the top now, and we'll make it a 5x squared plus 7x on bottom. All right, let's draw our graph. Crazy stuff in the middle, whatever you want. Okay, and then if your graph doesn't have an asymptote, we talked about last class, the ends aren't curving off to a specific number. So the end could be pointed, let's make this one go down, and we'll make this one go up. Now again, they could both be down, they could both be up, but they're not curving off towards a particular value because you do not have any horizontal asymptotes. Good with that? All right, the third option is Betsy. So they could be bigger on bottom, bigger on top, or they can be both equal. And if they're both equal, you're gonna divide the coefficients to find the asymptote. So I'll give you an example of that, and then we'll do a little sample graph. So for my example equation, remember we need equal powers. So I'm going to make the biggest power on top and on bottom both be an x3, just so that they match. So we'll do a 10x3 plus 5x over a 2x3 plus 7x. Okay, but remember, we're comparing those x's. So an x3 and an x3, you can think about that's kind of like it's a tie. Okay? And when it's a tie, when they're both equal, to find the asymptote, you're going to have one. But to find it, you'll divide the coefficients in the front. So in this case, what coefficients would I be dividing? 10 and 2 divides 2, 5. So this equation, my ends would go to y equals 5. Okay, and then I'll put because 10 divided by 2 equals 5. Okay, so that if you look back at your notes, you'll know where that came from. Okay? All right, give me a little sample graph. Crazy stuff in the middle, doesn't matter. And then I want you to sketch where 5 would be as a y value. So 1, 2, 3, 4, 5. And then I want my graph to approach 5 on both sides. So I'm going to curve this side up to 5. And then curve this side up to 5. Okay? But remember, middle of the graph is unknown. Okay, all we're talking about today are what the ends of the graph are doing. Okay? So beginning of this should be pretty easy. Okay, so we had a 0 asymptote for the first graph, 5 asymptote for the third graph, no asymptotes for bottom. So take a look at your first question when you're ready. Okay, first thing, I know this is an asymptote because x is going to infinity. So we talked about this last time, that if x is going to infinity, that is telling you to find the horizontal asymptotes. So in the first equation, the highest power on top is just a regular x. The highest power on bottom is an x squared. Which one's bigger?
Bigger on bottom.
Bigger on bottom, and if it's bigger on bottom, it's a bobo.
The 0.
So it goes to 0. Very good. Okay, next one. We're still going to infinity, and in my mind, I know that's the end of the graph, which means we're doing horizontal asymptotes. Top power is an x4. Bottom power is an x2. Who's bigger? Top, that makes it a bobo, a bottom, or Betsy? Bottom, and bigger on top means no asymptote, so it's a DNA. Okay, remember the N stands for none. Bobo stands for 0. Okay, for the third one, bigger on top, bigger on bottom, or both equal? Okay, it's an x squared. Then remember Betsy stands for both equal. Divide the coefficients. So I'm going to take 5 and 7, divide that, 5/7 is my answer. So for that one, your asymptote would be a fraction, but it's fine. All right, try the next row. Okay, number 4, we're looking for the biggest power on top, biggest power on bottom. What's the biggest power on top? Good, now notice they didn't come in order this time. Okay, but x5 versus x3, is that a bobo, a bottom, or a Betsy? Bottom means it's DNE, very good. Okay, next one, bobo, bottom, or Betsy? Betsy. Okay, so I have a 3x and a negative 5x. Very good. So for my Betsy, oh, you have a question?
Why is it?
Oh, I'm not crossing out, I'm trying to highlight.
I know, but I was like, why does it want to that?
So you're looking for the biggest power on top. It doesn't have to come first. So if I have an X3 or X5, think about you want to pick the biggest thing on top versus the biggest term on bottom. So same thing on this next one. My 5x comes later on the bottom, but it doesn't matter because it's still bigger than just a 3 by itself. So 3x and 5x is a tie. Then I divide those front numbers. 3 divided by -5 would be -5/3. Or wait, I said that wrong. 3/5. Okay. Last one. Bobo, Botten, or Betsy?
Botten.
Botten, and Botten means the answer is?
D&E.
DNE, because you do not have a particular answer. Good so far? All right, turn the page. All right, next row. Go ahead and run through those. So you're looking for the biggest thing on top versus the biggest thing on bottom. A Bobo, Botten, or Betsy for that next row. Okay, for 7, can you tell me your answer?
0.
Bobo is 0 because it's bigger on the bottom. What about number 8? Botten means DNE, and then the last one is, so it'd be 3/5. Good. Okay, now for your assignment today, some of them are going to come to you just like we've been doing, where it's already all times out for you. Some of the questions will come in what's called factored form. That's where it's not all the way times out, but you can still do it. Let me show you what I mean. Okay, for number 10, on top, I have a 3 times a 2x. What is that the same as? 6x. On the bottom, I have a 2x times a 3x. What's that? 6x squared. And then I do the same thing. Now notice, I'm not going to times out the whole thing because that's not necessary. I just need to know the biggest power on top versus the biggest power on bottom. Is that a Bobo, Botten, or Betsy?
Bobo.
Bobo goes to 0. Okay, next one. I'm not going to times the whole thing out and FOIL it. I just care about the biggest pieces. What's 2x times 3x? 6x what? Squared. On bottom, 4x times 3x is, and then x squared times x squared makes it a Bobo, Botten, or Betsy. Which means I'm going to divide those front numbers 1/2. Now 6/12 is correct. Okay, but delta math will count it wrong because it's not simplified. Okay. All right, last one like that. We have an x3 on top. What's our power on the bottom? X squared. Because it's an x times an x, then I know I have more x's on the top, which makes it a Botten or DNE. Good. All right, there are 3 types of equations that do different things on both ends. Okay, so in pre-cal, last year when you did this, you only did it with polynomials. So it's x3, x5, blah, blah, blah. Okay, we're going to look at different types of functions. Okay, and some of them do weird stuff. The first category is absolute value. So take a look at number 13. Your Bobo, Botten, and Betsy still apply, but the final sign for a Betsy could come out to be negative or positive. So let me show you what I mean. Look at number 13. We're doing x to infinity. What is the biggest thing on top? 4x. These are absolute value bars. That's not a 14. Okay, so 4x versus a regular x. Bobo, Botten, or Betsy? Betsy. And then it's 4x over 1x. 4 over 1 is 4. So far, everything's good. Now check minus infinity. Okay, so watch what happens here. When I take my minus infinity, I'm plugging it into the x position. Okay, my negative infinity, when I plug it into the 4x, is going to make it a minus 4x. Everybody good so far? Then I'm going to put it in absolute value bars. What does that do to the minus 4x in the middle? What do absolute values do? They turn it positive, right? So my minus 4x goes in, but then I absolute value it. Now it's a positive 4x. Okay, now let's talk about the bottom. I'm going to take my minus infinity. I'm going to put it in the x spot. Now it's a minus x. So is it still a Betsy? X and x, right? But my front numbers divide to what? This is a 4 divided with a minus 1 gives me negative 4. So I'm still getting 4 as my answer, but the first 4 was positive. The second 4 is negative. Where did the negative come from? X is approaching minus infinity. Okay, next one. Bobo, Button, or Betsy for number 14? Bobo, and Bobo gives me 0. Now, quick question. Can 0 be positive or negative? No, so you don't have to check weird stuff for that, right? Okay, next one. Bobo, Button, or Betsy? Betsy, and I'm going to what kind of infinity? Negative, then I have to just check. So the answer is going to be 2 over 1. The question is, should I keep it positive or turn it negative? Let's investigate. Okay, first thing I'm going to write down is 2x squared over x squared, because that's the biggest top versus the biggest bottom. We're taking a negative infinity to the top. What are the bars going to do? Okay, they're going to turn it positive, correct? So mark the top as positive, because absolute value bars always turn it positive. Okay, now on the bottom, I'm taking a negative, but I'm going to square it. So what's a negative times another negative when I square it? Positive. Then the bottom this time comes out also positive. Then 2 divided by 1 gives me 2. Okay. Take a look at the next one. Bobo, Button, or Betsy?
That's Boston.
Yes, and Button makes it?
It makes it DNE.
DNE, very good. All right, now for the bottom.
Oh, you don't have to check.
You don't have to check, because if it's a DNE, that's your answer. Okay? It's really only the Betsy's you have to check. Okay, look at 18. Okay, for number 18, we see that it's a Betsy. So we know that it's going to be a, hey guys, gentlemen. Okay, it's a 2x3 versus an x3. Okay, but we're plugging in a minus infinity. So on top, the minus infinity is going into what? Absolute value bars, which are going to turn it positive. Okay, gentlemen. Okay, but on the bottom, I'm taking the negative infinity and I'm cubing it. So a negative times a negative times a negative. Bottom will stay negative. And then 2 divided by a negative gives me good. Okay, we get the idea there?
Yeah.
All right, next section. So absolute values do weird stuff. Okay, square roots can also do weird stuff. So let's look at this section. You're going to do what I usually call like kind of bad math here. Okay, you're really just going to simplify the biggest thing. So if I have a 9x squared, but I square root it, what is that about the same size as? 3x. So I have a 3x versus a 2x. Now, we're square rooting the 9 to get the 3. We're square rooting the x squared to get the regular x. We're good with that? Okay, Bobo, Botner, Betsy.
Let's see.
Betsy, 3 divided by 2 is my answer. Because I'm going to regular infinity. Weird stuff doesn't happen at regular infinity. Okay, now look at B. I'm still going to get a 3x and a 2x, but what am I headed towards? And at the negatives, that's where weird stuff can happen in this family. So still put 3x over 2x. But now we're going to have to investigate whether it should come out positive or negative. So I'm going to walk you through it. Okay, because remember, absolute values always come out positive, but square roots are different. If I take a negative and I square it, how is the top going to come out? So I have a negative, but I'm going to square it first. Top has to be positive. Okay, but then on the bottom, I'm going to take my negative, I'm going to plug it into the 2x, and the negative is going to turn the 2 negative. So it's still a Betsy, but what's the answer? Negative 3 over 2. Good. All right, look at the next one. We're square rooting 16x6. What's the square root of 16? 4, and x6, if I square root it, goes to an x3. On bottom, we have a 3x squared. Is this a Bobo, a Bottom, or a Betsy?
Well, freshman volleyball players, please be dismissed and go to the locker room. At this time, please release freshman volleyball players to the locker room. Thank you.
All right. So Bobo, Botner, Betsy. Great. Okay, and we know that if it's a button, we don't have to check plus or minus. D and E is our answer for that. Okay, for the next one, we're going to minus infinity. Square root the top. Square root of 16 gives me what?
4.
X to the 4th gives me x
Squared.
versus a 3x squared. Does that make it a Bobo, a Bottom, or a Betsy? But I'm going to negative infinity, then I have to do a little sign check. Now, for the top, my negative infinity is going to be squared, automatically is going to turn what? Positive. On bottom, my negative infinity is going to be squared, automatically comes out. So this one, 4/3 is your answer. Okay, one more like that. Okay, 25x6, square root that for me. 25x6. What would that go to? Thank you. Okay, then on bottom we have a 7x3. That makes this a Betsy, which means it divides to what? 5/7. Okay, now remember, for positive infinity, you don't have to overthink it. But if it's a minus infinity, let me walk you through the steps. The first thing that you're going to do is you're going to raise your negative to the 6th power. If I take a negative and I put it to the 6th power, will it stay negative or will it turn positive? Positive. Now listen, even though eventually I square root it back to a cubed, it's going to lose its negative when I apply the 6. So my top 5 is a positive. Okay, now let's talk about on the bottom. I'm taking my negative and I'm raising it to the 3rd power. How will the 7 come out? Negative. Which means that that one's going to give me good. Okay, so far are you doing okay?
Yes.
Okay. Good. All right. We have to do 2 more sections before we can take a little homework break, and then we'll have to do a little bit more. So turn the page. I know it's a million questions, but they all like go pretty quick, you know? Okay. So if you have other types of functions, in pre-cal this did not happen. You were always doing polynomials. Here's the order. The smallest functions are sine, cosine, and then any other constants. Now, when I'm talking about a constant, I'm talking about like a 5 or a 6, not anything with an x. So a constant is like a number by itself. The next biggest category is any logs. That also includes natural logs. So this is going like smallest to biggest category. So this is the smallest. Logs are the next category. The third category is any power function. Okay, these are also sometimes called polynomials. Yep.
Polynomial. No.
It's okay, you can see it up there.
Well, he doesn't have glasses.
Oh, okay. You can just put power then. Okay, now real quick before we go into the examples. Okay, an example of a power or a polynomial, okay, is what we've been doing. X squared, x cubed, okay, x to the 100. Okay, any of those count as powers or polynomials because your x is the base. An exponential, okay, an exponential is when the x is up top as the exponent. So it would be like 2 to the x, e to the x, okay, 5 to the x. Any of those count as exponentials. Okay, so take a look at your next problem set. We want to find the biggest thing on top versus the biggest thing on bottom. So for number 22, the biggest thing I have on top is sine. The biggest thing I have on bottom is e to the x. Sine is in the smallest category. Where does e to the x go? Biggest category, then who's bigger? Top or bottom? E to the x, which is on bottom, makes it a Bobo goes to 0. Okay, next one. Next one, we have an x3. That's a power versus a log. Whose category is bigger? X3 is bigger, which makes it a bottom, which makes the answer D and E. Okay, number 24. Biggest thing on top, is it the cosine x or the 2x? 2x counts as a what? Which category? That counts as a polynomial. On bottom, my biggest thing is a log. Who's bigger, the power or polynomial on top or the log on bottom? Power, which makes it a DNE or a bottom. Okay, run through that next row. What? What did you say, Mauricio? I know, we're trying to get through this, okay?
No, I didn't. I just don't worry on
I mean, you could sit closer. All right, let's check your work. Come back together for me on 26. We're going to come back to 25. Okay, for 26, what's the biggest thing on top? Okay, what's the biggest thing on top? Girls, we ready?
Oh.
Okay, biggest thing is 2x. On bottom, what is it? 3x squared. So is it a Bobo, a Button, or a Betsy? Oh, we're doing 26. Bobo. And Bobo goes to 0. Okay, for 27, the top is a 2x. That counts as a power. Okay, it's a power of 1, but it still counts. Versus an x to the 100. Bobo, Button, or Betsy? Bobo, which means it goes to 0. Okay, for number 25. Okay, there's a pretty good chance you might have gotten this wrong. Okay, it is not a Betsy. Okay, so you have to make sure that this 20x plus 7 is inside the log. That means that the classification for the top is log. Okay, it's a log of 20x, but it still counts as a log. So this is a log on top. Who wins on bottom? The 10x or the 2x? 2x counts as an exponential. That's okay. So if it's a log versus an exponential, we know the exponential is the biggest category, makes it a Bobo. Okay. All right, are we good on that? Okay, we're gonna skip this section and we're gonna go to exponentials. Okay, so turn the page to exponential functions. All right, this part can get a little bit confusing, so let's all really try to lock in and pause side conversations so that we don't have to spend forever on this. Okay, exponentials do a weird thing when you plug a negative into the exponent. So if you have, I'm going to just take you back to pre-cal for like 1 sec. Do you remember that if you had 3 squared, what's that? What's 3? This is just side work. 3 squared is 9, because what do I do? 3 times 3, yeah?
Yeah.
Okay, 3 to the negative squared would become 1 over 3 squared. Do you remember that? And then what's 3 squared? So that would be 1 over 9. Okay, so what happens is when you place a negative into the exponent, it's going to fraction that term. Okay, so we're going to use that property whenever you have an x to a minus infinity and you have an exponential. So I want you to put right here, b to the minus x becomes 1 over b to the x. And this term, okay, always loses when you're doing Bobo, Bot, and Betsy. Okay, this is the equivalent of like a 0. Okay, so I'm going to put always loses, and hopefully you'll know what that means. Okay, but once you fraction your exponential, it doesn't win ever, pretty much. So let's run through some examples. Then we're going to take a little bathroom break, work on some of your homework. Okay, and you guys can chat during that part. So go to 37. 37, the top biggest thing I have is an e to the x. On the bottom, the biggest thing I have is an x to the 4. Who's bigger? And e to the x is on the top, which means this is a button. And it's a D and E. Perfect. Okay, now look at 38. I have an exponential. That's one of my 3 weirdos. And I'm going to what type of infinity? So this negative infinity is going to plug into e to the x, and it's going to turn it into a fraction. So I want you to rewrite that your e to the x is now a 1 over e to the x plus 10x4 over 3x4 plus 5. Okay, but it's the combination of a negative infinity with an exponential that creates this little baby fraction. Okay, now remember, does this still win? This always loses. So what's the next biggest thing on the top? 10x4 versus a 3x4 on the bottom. Is that a Bobo, a Button, or a Betsy? Which goes to 10/3. Okay, next row. We have, what's the biggest thing on top? Circle it. 3x4, what's the biggest thing on bottom? Okay, who's bigger, top or bottom? That makes it a 0 or a bobo. Very good. Okay, now I'm going to minus infinity. Which term is going to fraction? Good, so my 3x4 plus 2 on top is fine. But now it's a 1 over e to the x plus 10 on bottom. And remember, once your e to the x fractions, it doesn't win anymore. So who's the biggest thing on top now? 10 versus a 3x4, who's going to win? Top or bottom? Top. This is now a bottom, which goes to DNE. Okay, but remember, essentially, your 1 over e to the x always loses. Okay, next one. Bigger on top, bigger on bottom for 41. Good. That makes it a bobo goes to 0. Because remember, regular e to the x pretty much beats everything. Okay, but what about for 42? If I go to minus infinity, what happens to my e to the x?
1.
Okay, so I'm going to be lazy now and just put 1 over. Okay, without rewriting the whole thing. Now this loses. What's the biggest thing on the bottom now? Just a 6 versus what on top? 3x, who's bigger? Now the top wins, that's a DNE. Okay, let's do 43. We have a 6 log x on top, a 4x plus 10 on bottom. Bobo, Botner, bed C for 43. It is a bobo, goes to 0. On my other end, what's going to happen when I approach negative infinity with a 4 to the x? It's going to fraction. Now it's a 1 over 4 to the x, and 1 over 4 to the x doesn't win anymore. Now who's the biggest on the bottom? 10 versus a log. Who's bigger? The top is bigger. Logs beat out constant, so now it's a bottom or a DNE. Okay? All right, turn the page. 45 and 46, give them a shot. $45, what's your answer? Yes, good. 46, what's your answer? Okay, we get the idea? All right, last little thing I'm going to add is that if it's a bed C, you can't bed C two exponentials with each other. Okay, so bed C has to be that they're both an x5 or they're both an x3. If you have two exponentials, you're going to have to pick the bigger exponential to win. So what I mean by that is that if I have a 3 to the x or a 6 to the x, which of those is a bigger exponential? 6, and where's the 6, the top or the bottom? So that makes it still both, which would go to 0. Okay, so I'm going to put in the blank. It says bed C applies exclusively when you're dividing power or polynomials. Okay, you cannot bed C exponentials with each other. Okay, now think about 48 for a second. We're going to minus infinity. How many exponentials are in our equation? There's 2. They're going to both fraction because we're going to minus infinity. So it's 1 over 3 to the x plus 10. over 1 over 6 to the x plus 2. Okay, now remember, now that these are fractioned, I can't pick those anymore. Then what's the only thing left? 10 divided by 2 is 5. Okay? Questions on that? Okay, we do have a little bit more to cover, but we're going to take a little break so you can let it absorb, pull out your computer, and then you can't do the whole homework. So I'm going to pull it up and show you which parts not to try. Okay? Okay, you can do all of the type 1s and all of the type 3s. Okay, don't go past here. So I'll draw a line on it so you can see. Okay? Yes. Yes. Did you already put it back? Okay. Yes. Sure. Because you're not really, you're just kind of looking at each one. You're not like writing it all out, you know? You can do all the type 1s and type 3s. That's all you're doing for right now. All right, Michael. All right, Michael, you're reset. You said you did put one in or you didn't? Okay. Make sure you bring your ID with you, okay? And then you should pause where you're at. That's the last little section we'll have to do before we got into this. Uh-huh. So what's your top power when you multiply it out? Correct, and on bottom? So then you want to do -4 over -15 would be +4, because the negatives will cross out. Does that make sense? Good job. Sure. Okay, so times the biggest things on top. So what's x3 times -4x? You're multiplying.
Wait, how many questions we got right now? How many do you have to question?
But you're multiplying them. So if you have, so if you have x3 times -4x squared, what is that gonna come out to? Because you're not gonna times out the whole thing, you're just gonna do the top. Oh, here, I forgot you. Okay. Can you find it all right there? Oh, that's okay. There you go. So it's x3 times -4x2. What does that multiply to? To the atom, so 3 and 2 makes 5. Okay, now on the bottom, what are the two biggest x's we're gonna multiply? 5x3 and a what? Positive, -3, right? Like that. So what's 3 times -5 for the front number? -15. And then x3 and x2 make x5, because remember you're active. Okay, from there, is it a bobo, a bottom, or a vixen? But you're comparing the X part. Betsy, which means you're gonna divide the numbers to the front. Now, if it's -4 and -15, what's gonna happen to the minus? So your answer would be 4 over 15. Now, if that could reduce, you should do it, but 4 and 15 can't divide by it. Okay? You're welcome. Sure. Sure. Who was I resetting, Kendall? Oh, Adrian? You need one too? Okay. Okay, Adrian, you're good. Kendall, you're reset.
Is it still gonna get harder?
Yeah.
Oh.
I mean, at the beginning, you know, we try not to look too crazy. If people are still moving schedules. I mean, it won't get like horribly harder, but it will get harder than just literally that.
You think I'll survive these drinks since you had your last?
I do think you'll survive, but I think you'll have to change some patterns, you know, like talking through or having your computer out, or you know, that's probably isn't a good long-term idea. Need any help? Yes. Sure. All right, Maite, you're good to go. Yes. What? You want to use my iPad? All I've been doing is watching Netflix on this, so. I'll let you borrow it. Just make sure whenever you're done, get logged out, because I let people use it all the time.
It's like more.
You doing okay? Maite, how are we doing? Okay, so for the top, times the x's together. So you have an x3 and a -4x2. What's that gonna multiply to? So it'd be a -4 in the front, x5. Good so far? Okay, for the bottom, you have a 5x3 times a -3. What would that be? But 5 times 3. You're multiplying. Good. So look on the board, the top came out to a -4x5. The bottom came out to a -15. So we go about them, or that's. If they're both x5s, it's a bed seat, then you divide the numbers in the front, but if it's a -4 and a -15, what's gonna happen with the sides? So 4. Does that make sense? Yes. Sure.
Well, you're going back to defense work.
Kate, you're reset. All the level 1s, all the level 3s. You can do it, guys. Okay, well, let's see. You can sit on top. And on bottom of the side. So then it'd be bed seat, -7 or 1 would be. Oh, okay. You just need me to reset it. My bad. I thought you were understanding. All right, Asha, you're good to go. You would do the 5x3 times the minus 3x. Okay, and what's the top?
3x.
But no, you gotta time do that. Because you want the two biggest things out together.
Negative 4x.
Okay, so you had negative 4x5, and then what was the bottom?
Negative 15. X5.
So then if they're both negative, then the negatives, when you divide, would just give you 4/50. Does that make sense? That like the minuses would cancel each other out?
I'm employed.
Uh-huh.
Get it right, I'm employed.
No, I don't have. I won't have the baby till December. Not like January 1st.
I know.
I'll be back for sure before spring break, like in quarter three. Yes. Sure. Okay, so for the top, we're gonna do 5x times minus that. Uh-huh.
Somebody said so myself.
So look here, if you do 5x times a negative x, you're gonna multiply the 5 and the negative in the front, what does that give you? And then x times x becomes x. So now let's do the bottom. You're doing a 5x times an x, what's that? So 5 times 1 is up 5, and what's x times x? Uh-huh, and then you compare the x's. Is it bigger on top, bigger on bottom, or both equal? Then you're gonna divide the front numbers. What's negative 5 times 5? You're joking. Negative 5 divided by 5? It's 3. What did you say? She said 3. Oh, okay.
You was not.
Okay, so you're doing, what's the highest thing on power? X76 was the highest thing on power. So then it would be the limit. That uses this one. It's a bigger You see what I'm saying? That if that's a 76 power versus a 12 power, then a 76 would be
North is cute. I think
You guys almost, oh.
getting there.
And girl, you only did one.
I did two. I did two.
2, fine. Still bad girl. Not as bad. Yes.
Look at so
Uh-huh. Yes. Oh, Kate, you're in a set, so I'll just give you a new one. Did someone else need a reset? Stephanie. You're good to go, Stephanie. Oh, good. All the ones in, right?
What's the name of one? I don't know how you do it.
Your options do not get down.
Wait, is that an answer?
What?
It
It could be negative 49 and 9, yeah, that can't solve it.
I don't have to do it. I left them around. They're probably like, "Oh, it's actually-"
Good, oh, good. So, Julie, how we doing? That's okay. Now remember, you don't have to times the whole thing out. Just pick the two biggest pieces. Yeah, so times those. Yeah. So for the top, it'd be x3 times negative 4x2. What would that be? Five. Write it down. Okay, then let's do the bottom. We're just timesing the biggest two pieces. So it's a 5x3 times a negative 3x2. Okay, and now is it Bobo, Bodner, Betsy? But remember, you're looking at the x. They're both x5s. That's a Betsy, right? They're both equal. Then you would divide these prime numbers. You see how it's a 5 versus a 5? So then you divide. So your answer will be -4 over -15. But what happens when you divide this? That would be 4 over.
What's that concept? Then what is what is
Oh, yeah. This is what? Oh, in like sign language? Yes. Maite, did you put a pass in already? Okay, I got you. All right, go ahead. Ogo, did you need a reset? Got you. Oh, Ogo, you're in a set of 5, so it'll just give you a new one. But it won't hurt your grade. If you're trying to get to like 5, you could get 10, and as long as you eventually get 5 right, we won't. But if it won't give you a new problem and the X stays there, that's when I have to refresh.
You go with the thing.
Sorry. What's type 3?
You can do the type 1s and type 3s.
Number 2.
All right, finish up the one that you're working on, and then this is the last little section we have to get through today. Mauricio, you picked to be here. I'm happy to have you. Sadly, in 18. Okay, so turn to the section that we skipped. Look, you can do it. It's in like, I think a week or 2 that you can drop. But you have to wait till then. All right, last little bit of this. Okay, in your homework, if you noticed, okay, there's a section. Okay, I'm going to show you which problems this goes with. Do you see the questions where it says you can't just pick D&E? Okay, these are the questions that go with this section. Okay, so we're going to do the notes, and then hopefully we won't have to do any more today. We'll save the rest for another day. Okay, so if you get a button in that section, it won't let you just put D&E. It wants to know, is the graph going up or down? Now look at your front page. Do you remember that in the bottom section, either the end points up or the end points down? Do you remember that? So we're going to learn how to determine which one it is. But every single question in this section is a button. Okay, so you can check for each one, but I'm just going to save you the trouble that they're all buttons, the bigger powers on top. Okay, if you need to know whether it comes out as a positive or a negative infinity, you're just going to do a little sign check. If x is going to infinity, that's positive. If I raise it to the 5th power, how will the top come out? Positive, because I'm taking a positive and I'm timesing it by itself 5 times. So the top is positive. What about on the bottom if I square it? Positive. And what do you get when you divide two positives? A positive infinity. Now, again, how did I know the answer was infinity? Because it's a button, right? The limit doesn't exist. The question is, does it come out to a positive or a minus? Let's check 31 right here. Same question, but what am I approaching? Negative infinity. So if I take a negative infinity and I raise it to the 5th power, we already know it's a button because the bigger power is on top. Negative to the 5th, how is it going to come out? Negative. On bottom, I have a negative, but I'm going to square it. How is it going to come out? Positive. And what do you get when you divide a negative and a positive? Negative infinity. Okay, but again, how did I know it's infinity? Because it's a button to begin with. Okay, look at 29. The biggest thing on top is an x5, but I'm going to subtract it from 7x. How is the top going to come out? I'm plugging it into an x5, so that's going to be positive, but then I'm going to minus it. How's the top going to come out? Negative. On bottom, I'm taking an infinity and I'm cubing it. That's going to come out how? Positive. What happens when you divide a negative with a positive? Okay, your bottom is a minus infinity then. Okay, but they're all bottom, so they're all either infinity or negative infinity. Okay, for 32, it's still a bottom. I'm plugging in a minus infinity though. What's going to happen when I do minus infinity to the 5th? It'll come out positive or negative. Initially, it'll come out negative, but then when I combine it with the minus, it's going to come out positive. So the top's a positive, but on the bottom, I'm taking a negative infinity and I'm cubing it. How is it going to come out? Negative. And when I divide a positive with a negative, it's going to come out negative. Okay. Next one we're doing is 30. I have an x3 versus an x2. It's a button. That means it's either infinity or negative infinity. Okay, plugging in infinity, how's the top going to come out? Positive. Plug it into the bottom, how is the negative 3x squared going to come out? The x squared part will come out positive, but then if I times it by a minus 3, it's negative. And then if I divide a positive and a negative, the overall result is negative. Okay, check 33 for me. I have a button. I automatically know it's infinity. Question is plus or minus. Negative infinity to an x cubed, how does it come out? Negative. But negative infinity squared comes out how? Positive, but then I multiply it by the negative 3 on that term, it's going to come out negative. And when I divide two negatives, I get a positive infinity. Okay, last row, you're doing great. Negative infinity on a 49x4 over an x. What is this reduced to? You're going to have to square root that first term. 7x what? Squared. Oh, versus a regular x. Did it come out to be a button like we said it would? Yes, so we know it's infinity. The question is plus or minus. I'm taking a negative infinity and I'm squaring the top. How's it going to come out? Positive. What about for my regular x if I plug a negative infinity there? Negative. And a positive and a negative divide to a negative. Okay, next two have absolute values. So the top automatically is going to come out how? Positive. Absolute values turn everything positive. But if I do an infinity cubed, that's also positive. And two positives divide to a positive. Now for 36, I want you to write in a negative because I forgot to put it. Otherwise, they're the same. How's the top going to come out if I have absolute value bars? Automatic positive. But how is the bottom going to come out if I have a negative and I cube it? Negative, and a positive and a negative divide to a negative on my infinity. Does that make sense? Ish? Okay, we are going to finish these notes and this homework next class. Okay, so you can now do the ones that say don't put D&E. And then you have 20 minutes. We're done with notes. You're just now finishing those last few questions.